Hello everyone, today we're going to be learning about how to use equations to help us solve word problems. So our learning goals for today are to use equations to solve these types of word problems and to use a problem solving approach when we're trying to solve problems that have equations in them. So generally it's really helpful to solve word problems using these 4 steps. The first step should be to choose your pronumeral. So that's where you're introducing a pronumeral. So when we do the first example down here, that's where we're saying let n be something. You can choose whatever letter you would like. The second thing is you then want to translate the words in your question into an equation. So you're then going to want to make some sort of equation. Third step is that you're going to want to solve it. And then the fourth step, you're going to want to actually answer the problem in words. So if you just follow those 4 steps every time, you should be fine. So we're going to have a look at a couple of examples, and I'll leave some of the examples for you to do as well, and then do your summary and have a go at your questions from your text. So first example, it says when 6 is added to 4 times a number. So just that first bit there, when 6 is added to 4 times a number, the result is 50. So, and the question wants us to find that number. So the first thing we do is to introduce a pronumeral. So I'm going to let n be the number we are trying to find. So this first bit here where it says when 6 is added to 4 times a number, that would be 6 plus 4n, because 6 is added to 4 times a number. You could also write that as 4n plus 6, and it says the result is, which implies equals 50. Okay, so that's how I get that equation out. Often the hardest part of this section of work is just coming up with that equation. But once you've done that, it's usually pretty good. So now I want to solve my equation. So I'm going to do the opposite of plus 6 to both sides. So I'm going to subtract 6 from both sides, which is going to give me 4n is equal to 44. And then if I divide both sides by 4, I'm going to get n is 11. And then I'm going to go, therefore, the number is 11. Okay, so I've actually answered the question in words. I've shown my algorithm and my working. Keep in mind this little symbol with 3 dots here, that just means therefore. Second one is very similar to that. So it says the sum of a number and 9 is multiplied by -2, and the answer is -8. Find the number. So again, I'm letting n be the number we're trying to find. So it says the sum of a number and 9. In other words, n plus 9. And it's saying that is multiplied by -2. So I'm going to put -2 at the front of a bracket because it's -2 multiplied by that whole sum of the number and 9. And it says the answer is -8. And so that gives me this equation here. Now, there are 2 paths you could follow from here. You could either expand the left-hand side bracket and then go ahead and solve it, which is what a lot of students do, but I would encourage you to look for a shortcut. And the shortcut here is to do the opposite of multiplying by -2 to both sides. In this case, we divide by -2 to both sides. And what that allows us to do is these -2's here give 1. So I end up with n plus 9 is equal to 4. And then if I take away the 9 from both sides, I'm going to end up with n being equal to -5. So therefore, the number we're trying to find is -5. And I'm done. Remember, you can check your answer by substituting it back into the original equation you made. Or just using the rule, the sum of a number, so -5 plus 9 multiplied by -2, is that -8? Yes, it is, so you know you're correct. Okay. All right, then we get into some more problems where you have to kind of think about things a little bit more than those simpler ones. So let's have a look at this. It says, in a given amount of time, Jamie drove twice as far as Rhonda. It then says, altogether, they drove 90 miles. Okay. And the question wants me to find the number of miles driven by each. Okay, so what I've done is I've highlighted the key components of the question. And I'm going to start off by letting the number of miles driven by Rhonda be R. Okay, so it says here in the yellow bit I've highlighted that Jamie drove twice as far as Rhonda. So I'm going to say that J is equal to 2 lots of R. It says altogether they drove 90 miles, so I'm going to go J plus R is equal to 90. And what I'm going to do now is, seeing I've got this top equation here, which tells me that J is equal to 2R, well, wherever I see a J in this second equation that I've got here, I'm going to put a 2R because that's what J is equal to. So I'm going to go 2R plus R is equal to 90. Collecting my like terms, 3R is equal to 90. Dividing both sides by 3, R is equal to 30. So Rhonda drove 30 miles, and they wanted me to work out how many miles driven by each. So if she drove 30 and altogether they drove 90, therefore Jamie drove 60 miles. And that fits the question because it said in the yellow that I've highlighted here that he drove twice as far as Rhonda. Cool. So just remember, at any point, if you want to go over something again, you can pause the video, rewind it. Going on to the next one. It says the length of a rectangular map is 15 inches and the perimeter is 50 inches. Find the width. Let the width of the rectangular map be W. So the first thing I'm going to do in this problem is draw a rectangle. It tells me the length is 15 inches and the perimeter of the whole thing is 50 inches. They want me to find the width. Okay, well, what do I know about a perimeter of a rectangle? I know that 2 lots of the length plus the width is equal to the perimeter. Okay, and they're telling me that the perimeter is 50 inches. Notice we introduce a pronumeral here by letting the width be W. So at this point here, I'm just solving this for W. Instead of expanding though, I'm going to divide both sides by 2, take a shortcut, and I get 15 plus W is 25. If I take away that 15 from both sides, I get W is 10, and therefore the width is 10 inches. Okay. So hopefully you can see in those problems that we can combine the skill of changing word problems into math symbols when we're finding equations. So I would like you to have a go at these ones here by yourself. You can work with others if the teacher's okay with it. Question 6 is very, very similar to the one that we just did. And question 7 is a little bit more tricky, but I'd like you to have a go at it. So I'd like you to have a go at the questions remaining in the booklet, write down a summary, and then I'd like you to have a go at these 2 exercises, 2G and 2H. Hope to see you guys soon.